Yeah, he said there were too many people getting awards for things they applied to, and not enough people getting awards for things they don't.
Yeah. I guess we should start.
We should start. There'll probably be more people working their way in.
We shorten time, so we should.
I guess I'll start off. Blue sheets are coming around. Luckily, we all fit on this side of the room. So all you folks over there, shadows, hello. This is the main IETF 104 ICNRG meeting. We had an interim last Sunday. We've seen a number of you, almost all of you then, but some of you not. So we'll take a little bit of time to go through that. So we have a note taker. Everyone thank Marie-Josée Montpetit, who took notes on Sunday and has agreed to take notes today. Saves us a lot of time to not have to embarrass people into trying to do it at the last minute. To start off, you all should be aware of the IETF policy, which deals with the disclosure of intellectual property and behavioral and other aspects. So if you haven't looked at it recently, please look at it. Keep going. So here's all our administrative information, where the mailing list is, where our web address is, where our wiki is. There might be a couple people in the room that don't know us. I'm Dave Oran. This is Bourdier Odelman. This is Dirk Kutcher. And we, as a team, have been co-chairing ICNRG for 8 years.
Quite some time.
Yeah, 7, 8 years, something like that. No, not that long. Maybe 6 or 7 years at any rate. If you'd like to contribute to the note, oh, you're not using the Etherpad, right? You don't like to use the Etherpad. Never mind. So if somebody wants to use the Etherpad, go ahead. But Marie-Josée taking the minutes on a separate thing. And you can track all the meeting materials for this meeting. All people's presentations have been pre-uploaded on the material site. Keep going. So we have a pretty packed agenda, so we'll be fairly rigorous about enforcing time limits today. We actually had to push one talk from Sunday to today, so thank you, Ridong, for agreeing to do it today. The theme here is twofold. First, we have some update. We have a technical talk on hop-by-hop authorization, a bunch of document updates, which hopefully will go reasonably quickly, just to make sure people are up to date on where the documents are and what our plan for progressing them is. And then the one sort of longer section where we're going to try to make progress on how we start introducing quality of service ideas and mechanisms into our ICN architecture. And for that, we have sort of like 2 reasonably content talks. If we have time, there's some stuff that I and Ili Moisenko did a while ago, which people may have forgotten about. And if we have time, I'm willing to do a refresher on that. And then a quick thing on an open call for next-gen internet from the EU, so that people are aware of things that they can apply for. Next. So we did an interim on Sunday. Here's the list of topics we went through. There's a few document updates, but a number of fairly deep dive technical talks on keyword naming, using ICN as the gossip part of doing blockchain-like protocols. We had updates on the name resolution services. I'll say very briefly on that. We'd like to complete that work, but there hasn't been a lot of participation, and the folks doing it are going to be moving on to be doing other things. So we'd like to wrap that up as quickly as possible by having people review the latest drafts and reaching closure for RG last call and progression of those on the mailing list. We had 2 good talks, one on where NFN, name function networking, has gone, and a, shall we say, somewhat controversial talk on modeling all communication needed to maintain append-only logs using broadcast protocols. a discussion or a quick summary of a workshop that we did on Compute First Networking at Berkeley back in January, much of which is applicable to this group. So look at the slides there. And then we started a discussion of management tools, which most of the time went into getting people back up to speed on one of the main management protocols under consideration, which has been adopted as an RG document called CCN Info. So questions or comments on the Sunday in room? Yeah.
Did you skip over the NDN, or did I just not listen?
Yes, I skipped over. I'm sorry. Jeff Thompson gave a really nice talk on the current releases of the NDN programming tools libraries. Folks, you're not going to be very happy over there. You're not going to be able to see anything or communicate. There's still plenty of room over here. Unless you want to hide, in which case I suggest you sit in little chairs that we can't see behind the pillar.
The front row is almost empty.
Front row, there's room everywhere. All right, so yeah, so that was a fairly comprehensive review of those tools. They've made a lot of progress on making it easier to write applications on top of NDN in the last year or two. Thank you, Bourdieu. Skip over this.
There is.
Why don't you take over on the RG draft status?
Okay, we're going to go quite quickly around this. Finally, we have the CCN drafts in the RFC editor's queue, so that's great. Fleck, we would like to conclude, but there is no one really picking that up. But if someone would like to do that, please do.
If somebody's willing to do it.
Yeah.
Right. You don't have to like it. You have to be willing to do it.
Disaster has got its final updates and is going to IRC review now, or should it be IRC poll, right? Yeah. Or should it be IESG poll? No,
we just sent it to the final IRSD publication poll.
Okay, yeah.
Right. So for those of you who don't know all the administrative crap, so any document that has passed working group, research group consensus and people agree it's ready to go, goes through a review by people on the IRSG, the Internet Research Steering Group, provide comments, look at it for technical quality. When not satisfied, there's a final publication poll to the IRSG, which is normally pro forma and relatively quick. And then there's two stages after that. The next stage is it's sent to the IESG for them to confirm that it does not conflict with work going on in existing IETF working groups. That also is pretty much pro forma if in fact it doesn't conflict. And then on to the RFC editor for final editing and publication. So these have finished all of our review processes and are at this point, it's a mostly administrative set of steps to get it to publication.
Yeah, so it's the disaster scenarios and the deployment considerations. Both the same goes for both of those. Then, as we are out of time, or have very short of time, I'm not going to go through all this. You have all the drafts here in the slides if you want to look at it. So yeah, well, there are more. So let's get back to the agenda. So I suggest we just start with Rui. Please come up there, find the slides.
Is he here? Yep. Oh, there you are. You were hiding behind.
Okay.
Well, blue sheets, by the way. Blue sheets. Folks, just move on to this side. It's nicer for you. You'll see more if you. Please keep the blue sheets rolling around.
You got the clicker, yeah?
So we actually.
Oh, right. We forgot one thing.
Here. What?
Yeah, but we forgot one thing before we start.
Oh,
You want
sorry.
to do this, Dirk?
Oh, sure.
Sorry.
All right. Quick reminder. So there's the ICN conference this year in September, and it's going to be in Hong Kong at Hong Kong City University. Next slide. We have general chairs from Hong Kong and the US, TPC chairs, John Rastowski and Jan Svaras. Maybe just move on a bit quicker. So what may be interesting to you is, so the TPC chairs decided to slightly change the, say, approach to the conference this time to reflect the maturity of the field. So if you look at the call for papers, you will kind of see this different set of topics. We think it's a good approach to strengthen the program. We also hope to get new communities interested and submitting papers to the conference. What's new is that so we will apply a double-blind review process this time. We have sufficient data that this normally increases the quality of the process. So when we do this for ICN as well. Next slide. And so the areas of interest is core ICN, Börje.
Yeah. We decide because we already understand.
Yes, I would prefer if I could have a look first before.
Why don't you go look at the call for papers? This is just a summary of the call for papers. But the important thing here are the dates.
Yeah.
So the deadlines will be hard as usual. Start working on your paper now if you haven't done this already. Looking forward to your submissions. And now we can switch to Renong.
Thank you, Chair. Thank you, everyone. I'm Renong from NRCT, and today I will present the hope-by-hope authentication with suspension chain model. This work has been published at the IETF transaction on network science and engineering last year. This work with my colleague Doshi. This outline of my presentation. First, I will introduce the content-centric network and adversary model and traditional approach, and propose the hope and conclusion. I think most of you are familiar with this slide. There are simple introduction of the content-centric network. There are two kind of packet type of interest and data, and the consumer sends the interest to the network, and the copy holder replies with the data, and then this consumer can retrieve this data from this closed cache data. They are publisher, consumer, and copy holder. Copy holder can be the caching router and the publisher. The adversary model we consider two kind of attacks. One is content poisoning attack. That is, the attacker can impersonate a copy holder to provide fake data. Currently, the content is only signed by the public key of the publisher, so it is impossible to verify the publisher's validity unless all the routers use the authentication service of the CA. And another attacker we consider is interest flooding attacker. That is, the attacker impersonate a consumer to request the data. There are much existing work on restricting the interest sending rates, but it is still impossible to verify the consumer's validity unless all the copy holder use the authentication service. This slide shows the influence of the content poisoning attack. There is an attacker, this router caches the fake data. This is the true data. This router is close to the consumer, so the consumer always gets the wrong data from this attacker. And also this fake data can be cached, field cached, and which include the router as various sprays. And the consumer too retrieves also always retrieve the fake data. So the routers need to verify the data before caching. The fake data need to be deleted from the before caching. And the consumer need to verify the copy holder. Consumer need to verify copy holder and the path to identify the polluted entity besides the data verification. For the interest flooding attack, the attacker can flood the interest to the network to malfunction their routers. So even the interest can be reduced by the rate limiting. Some malicious interest can still reach the copy holder. And so it will be effective to inhibit the interest flooding attack if the router can verify the interest before applying the data. So we need the additional authentication service for to inhibit the malicious fake data attack and the interest flagging attack. So the traditional authentication service here is that there is a centralized certificate authority. There's a public key infrastructure. So when there is an incoming packet, the routers need to interact with the certificate authority to perform the certificate discovery and acquire the necessary certificates. So there is, when it forwarded to the next router also need to perform the certificate discovery and acquisition. So there is additional messaging for the authentication, which needs it to be invisible during the data retrieval. Obviously there is a scalability problem. For the router, it is highly costly for each router always needs to verify the signature of every data in every interest. And for the consumer, the public key of all the potential copiers should be provided to the user beforehand. To solve this problem, we propose a hop by hop authentication mechanism. The key idea here is the hop auth construct the certificate chain between the consumer and the publisher, and the consumer between consumer and the copier along the path. So the hop auth can be certificate authority independent. Yet it also can be partially used CA-based trust to shorten the length of the certification, because the certificate chain, the length of the certificate chain, if it is longer, the trust will decrease. So we use the CA-based trust to enhance the security. The packet forwarder can also be performed with the connection of the certificate chain without extra messages. We extend the entity trust graph with the application trust graph. So the effect of this hop auth is that the routers can cache data only after authentication. And the publisher authentication, copier authentication, and the consumer authentication, and path authentication can be achieved as required. This slide shows how to issue certificate and how to keep the certificate. This certificate management, I think. There are two kinds of entities. One is the physical entity, and another is logical entity. Physical entity is the entity that communicates using a physical device, such as router or mobiles. And the logical entity is the entity that is involved in the application. For example, the authorizer or sub-authorizer publisher. In the hop auth, the certificates are issued based on the trust relations. For the physical entity, there are mainly two kinds of the trust relation. One is label-based trust, and another is CA-based trust. And for the logical entity, is the authorization relations. So the certificates are issued based on this kind of trust. For the physical entity trust, there are, for example, two routers are labels, so they are issue certificate to each other and keep the certificate for each other. For the CA-based trust, the CA can issue certificate to highly trustable physical entities. For example, CA issue certificate to this router, and these two routers are in the same form the highly trustable router group, and then they issue certificate to each other if they are close enough. For the logical entity trust, the authorization relation with the trust are used. For example, the logical entity who administrates the news can issue certificate to the logical entity who manages the subcategory of news sports, and the further issue certificate to the logical entity who manages the subcategory of news, sports, and Olympic. This slide shows how to construct our proposal certificate suspension chain. There is a user X to retrieve the data. There are these two figures shows the one is shown to retrieve the data from publisher node, and this figure shows to retrieve the data from copier of routers. User X sends the interest to the next hop router, and then append with this certificate next hop the certificate from next hop to it, and then this RK also append the next hop certificate to it, and then this certificate are appended hop by hop. And finally, when this interest reaches publisher node, the publisher node can verify the interest with using this certificate chain. And the publisher node also holds the certificate from it to the logical entity who administrate the news, sports, tennis, and then it append the certificate. This is the certificate chain. It already holds the logical certificate chain, and then it sends the data, reply the data with this certificate chain and the certificate from next hop to it, and then this certificate will also connect it hop by hop, and finally this this data with certificate chain reaches user X, and then user X can verify the certificate chain from user X to the logical entity who administrates the news, sports, tennis, and also can has the certificate from user X to the PN to the publisher node, and verify the copy holder, and also verify this path. So for this figure shows the if the data is cached by the routers, user X also the similar process. The user X sends the interest hop by hop with the connection of the certificates, and then R1 can verify this certificate chain and the interest, and can if the certificate certificate cannot be verified, it will be dropped directly. If it can be verified, the data will be replied. This also the part of the certificate chain has been cached here from R1 to the publisher, to the logical entity publisher, can has the certificate chain 2 here, and the R1 appended the certificate from R2 to R1, and then hop by hop connected the certificate, and also use the CA-based tracer to shorten this certificate chain. So after this data reaches the user X can verify this certificate chain, verify the publisher, verify the copy holder, and verify the path.
Just 3 minutes left.
Okay. This is the simple introduction of the certificate chain model. This is the label-based trust for the certificate chain, and this is a logical certificate chain. And we use a CA-based tracer to shorten the certificate chain length. For example, here you will use a CA-based tracer from certificate, use a certificate RK-1 to R2 to replace the certificate subchain from RK-1 to R4 to R3 to R2. And this is our suspension chain model. This shows our security level. We identify 3 security levels as follows. The security level, lower security level is only for the publisher authentication. And for the one piece of data, the suspension is constructed only once. For the security level 2, besides the publisher authentication, we also consider the copy holder authentication. For the security level 3, besides the publisher authentication, copy holder authentication, also consider the path authentication. And this is the packet format, packet format for our packet hop host. We added the hop by host header here. There is the type, names, therefore certificate, and the total names of the inserted certificates, TLVs. This certificate chain, certificate 1, 2, 3, 4. Here, we know that the certificate size might be affect the performance of our hop host. So we investigate the certificate size. We can get some reference from here. The data transport near security in constrained environment for the ECDSA with key names of 256. The certificate size is 91 bytes, and this is has the same security strength as the RSA with the public names of 3072. Conclusions. As the authentication protocol, we propose a hop host to enable hop by hop certificate connection and authentication. As a trust model, we propose a suspension chain model, which was web trust and partially CA-based trust to construct a suspension chain to enable content-centric trust. We will write an ID for the hopefully for the ICNR. I think this work is useful and available. Any comments? Thank you.
Thank you. Other questions?
Marie-Josée Montpetit, MIT. What is the link between what you're doing for this and what people are doing in distributed authentication, like blockchains and stuff like that?
Blockchain-based authentication is different from ours. Blockchain is another additional blockchain system. They are managed all the certificate, and then we if we try to realize the router authentication to the certificate to the data, then the router need to interact with the blockchain system.
But do you think we need both, or we could live with one or the other?
Maybe we need both. The blockchain-based system, certificate management is also very interesting.
Because my opinion is actually, I think it's a either or, it's not both, but that's my opinion. Thank you.
Hi, Dave Oran. I have one clarification question and one comment. So the clarification question is, what do you lose if not every hop does this? In other words, some hops have the capability to do authentication on that hop and some don't. Does the whole thing break, or do you still get some improvement? I'm thinking about the incremental deployment problem.
Implementation problem. You mean why the routers to issue certificate to each other?
Right. What if there's an intermediate router between two routers that know how to exchange certificates? Is that a problem?
Yes, we consider use some CJ based CJ like mechanism. Use the public key, the hash of the public key as the identifier, and then verify each other. Neighborhood, and then you certificate to each other.
Okay, and then the comment had to do, if you put up the slide about the behavior for checking signatures on content by caches. Can we move to that slide real fast? I just have a quick comment there, because we actually have the CCNX spec has actually a specified approach to that. Well, what you say is that you still cache the content and you do the integrity check in the background.
Yes.
All right, so there's two aspects of that to think about. One is that what CCNX says is that if you haven't authenticated the content, you can still store it, but you're not allowed to return it to a user. You must bypass the cache if you haven't yet had a chance to check the signature. So you can store it in the cache, but you're not supposed to answer an interest. And then the second part of that is you want to be very careful to not evict authenticated content in order to store content you have not yet authenticated, because that won't pollute the cache, but it could cause a cache. What's the right? Come on, there's cache pollution and there's cache thrashing. Yeah. So a couple things to think about on the cache behavior.
Okay. Let's move on.
Let's move on.
Thank you, Roland.
Nice work.
For the benefits of the people online, we use microphones.
But he's supposed to be over here because then he can see the screen.
But yes, you want to maybe.
Do you want to stand?
Yeah, I can also look here at the slides here. It's okay for me.
Which do you prefer?
It's okay here. Is it better?
Yeah, if he's over there, then you can see us, and that's no good, right?
On the X.
There's a plan behind this, so you have to.
So does it figure out how to turn the camera by itself?
Yeah, it figures it does.
Wow. Surveillance standardization.
Well, start talking.
Okay, so I have no slides yet.
Slides up.
Okay, so my name is Cenk from Hamburg, and I'll actually present two things today. First is updates to the ICN Open draft, and second is some experimental results that we did for a paper. And I will start with the updates first. So we are at version 2 now since a couple of weeks, and we did basically two major changes to the draft. We first added like a guidance section for implementers to ease the efforts of implementing. And the more or the better thing is that we also made use of a space-efficient compression format to represent time periods. And this is the time TLV that I want to present now. And the time TLV is actually work done by the MANET working group, by this group, and they especially made use in the OLSR routine protocol for this. And the time TLV is actually an encoding to represent time periods, and they used 1 byte. And in this 1 byte, they use 5 bits to express the exponent and 3 bits to express the mantissa. And as you can see by the formula, you can also look this up online in the RFC 5497. They are able to use to represent with this 1 byte a wide range of time periods with, of course, less precision. So here you can see, for example, using a constant 1 divided by 1024, that you can achieve as a minimum value 0.9 milliseconds, and you can achieve the maximum value 45 days. And as you can see in the picture in the bottom right, that's the actual distribution of the values. So most of those values are in the lower range. Then you have, of course, a few values to represent the higher ranges. And we took this work from them and want to apply this to the ICN Open. And what we basically did is, the earlier approach was to just cut off. The CCNX and NDN use actually like 4 bytes to represent these time values. And with 4 bytes, you can achieve the same range. So you get like 45, 48 days with 4 bytes representing milliseconds. And what we did before was just cutting to 2 bytes, which of course is not so good, because then you also only have 64 seconds to represent. So our initial thought was, why not? It's an IoT. But actually it makes more sense to have a wide range and to support those values. So we just took those 2 bytes that we had anyway, and now we use the work of them and use a time TLV. We have the same exponent size, but we have a bigger mantissa, so we have more precision. And here you can also see the values, 0.9 milliseconds for minimum and 48 days for maximum. So what you can actually, we use this time TLV for the interest lifetime and content freshness because they are time periods. In CCNX, you also have absolute time, which is used for the content store and content caches. We can represent this, of course, with this approach. And there's one, let's say an issue here. Using this formula, you can't express 0 because the minimum value is 0.9 milliseconds. So what we did, we defined, okay, if the time code, if A and B are 0, then we want to represent 0 because some protocols or specifications may use the 0 value. For example, the CCNX semantics or messages draft is using the 0 or the interest lifetime of 0 to say, okay, don't open pit states or don't use returning data and stuff like this. So we defined this, and you can see the minimum maximum. It's stays the same. And there's another problem, or you might say it's a problem, and because we don't know what the application is going to use as a time value. It might not fit in this, or it might not use a valid time value that we can represent in the time code. So there are some solutions to this that we try to outline in the drafts. You can, of course, round up the value to a valid time value, which does not always work, especially if you're signing data, then you don't want to change the packet. If the time period is inside the security envelope, which is true in the NDN world for the freshness time of data. For CCNX, I think it's in the hop by hop section, which is not in the signature.
Can I ask a question here? Is there any reason we shouldn't just deprecate the existing inference lifetime and freshness fields and replace them with this, in which case there's no confusion? And if you signed it, you'd be signing the right thing?
This it's of course not my decision, and I would be happy with that.
Well, it's interesting. The group should think about it because, again, these are experimental RFCs and we can change them. We don't have to worry. The backward compatibility is not nearly as strong a consideration. And my intuition here is that this is universally better. There are no downsides to adopting this as the way to represent interest lifetime and other time scale fields.
Yeah, I mean, I have to say for high performance stuff, of course, this hurts more than just using 4-byte, like what CCNX and NDN do now. It's much easier to encode and decode those values. And here, of course, you have to do calculations, but it's, I'm in the IT world anyway, so. And now we come to
So the cost is actually doing the clock queue, right? The clock queue for expiring things. That's where all the cycles are. The encoding and decoding is, small compared with maintaining your clock queue.
Yep. So I want to move on to the results that we did for a paper for the networking conference of this year. And here we have a little simple setup. We have 3 IoT devices, class 2 devices, limited resources, and we are comparing 3 stacks. So we have one is co-op UDP IPv6 open stack, the typical IETF stack. Then we use NDN over 15.4 and we use NDN over ICN LoWPAN over 15.4. And we have consumer forwarded producer, and we have 2 name configurations. The first name is expressed as name short, and you can see org example and stuff. And the red part of org example is the thing that we used in the stateful compression to elide the name. So it's not there when we are sending the name. And in name long, you can see that we use bigger prefix for the stateful compression. So we compress more. So we have these 2 configurations, and we go on, and here you can see the average processing time per each role and each stack. I will just zoom into the NDN stuff. So here we see that actually for the consumer and producer, you can see the green part of the bar is the link layer processing time. The yellow part of the bar, this is what is added in the ICN LoWPAN configuration. This is the actual processing in the LoWPAN. And then we have the red, this is just the application, so everything above 6 LoWPAN or ICN LoWPAN. So what we see here is basically we add, of course, processing time. Yeah, we are doing on a convergence layer, but we also can see that on the link layer, we reduce time by sending less bytes or handing less bytes over to the buffer transceiver. So in total, we actually don't add more or significantly more processing times in these scenarios. And then we look at the message sizes, and the message sizes here over the air. And again, for all those roles and configurations, let's just zoom into the NDN part. And here we can see that depending on the configuration, we even reduce messages. We are doing compression, so we reduce messages for the forwarder, even by almost more than 50%. And we also did some measurements, energy measurements. So on the y-axis, you can see the current draw as a function of time. Let's zoom into the NDN world. And here you can see, almost.
Co-op.
Yeah.
Oh, no.
You can see that for almost all, we reduce the time and flight of each packet by almost 50 to 40%, which of course translates to less power consumption. Let's zoom into NDN, and here you can see that we have this is per interest data transaction. So we gain like 100 or reduce the energy consumption by 100 to 300 microjoule for one interest data transaction. So we reduce also the energy consumption. And as an outlook, we add, of course, minimal complexity. This is, of course, always true with the convergence layer. But we have, all those benefits, of course, outweigh the things that I just said. And the next question actually would be, and also to the chairs, how we should proceed with this draft. It is out there. Should we? Yeah, this is basically where I stop now.
Yeah, first of all, this is great work. Thanks for doing this. It depends a bit what's on your plan. Do you have further work in the pipeline? Or?
The state as is actually quite It's actually quite major, I would say.
Mature.
Mature, as is.
Okay.
I mean, the state of the draft. Of course, it depends on feedback and if there's like more things that other people see that I don't see.
Right. So who has read the conversion? Okay, so that's a good indication that we need more people looking at this, because I think it's we think it's really important work. It really also clearly demonstrates very nice properties, and we want to publish it at some point as an experimental RC. In general, how we normally work is the authors kind of have to give us a signal when they think it's ready. Okay. And but I'm guessing what I'm hearing from you is that you're not quite sure. You would probably like to get some more feedback at this point.
I mean, sure, especially from NDN and CCNX experts.
Right.
But can we ask, are there anybody in the room that's willing to review this draft? Okay.
Yeah, Cedric. There's also the question about this time, what Dave was raising, about the time development. I mean, first of all, I guess it's a discussion on the mailing list. We can initiate this. But I mean, given that there is a consensus on that the time TLV should be changed or the old one should be deprecated. Question is,
Well, that's what I was proposing.
yeah, sure. But the question is how to do this. Should this be a separate document to deprecate?
Yes.
I think we'd reissue the messages draft, the
Okay.
CCNX messages draft, and deprecate the old TLV, and tell people to use the new TLV.
Okay.
I mean, procedurally, that's what one would do
For CCNX.
for CCNX. I can't, unfortunately, tell the NDN people how to change their specs. Maybe you figured that out after 8 years.
All right.
We can take an action to talk to them then.
Oh, yeah.
Yes, I'll take an action and we'll also talk to the NDN people. But then I'll wind up talking to them about absolute clocks and we'll have to go out for beer.
Okay. Thanks, Shink. Okay. Next, ICN 5G. Rashid? Thank you.
Hello, everybody. I am Debashish Purkasta, and I'm presenting on behalf of my colleagues. So this is the draft which is enabling ICN in 3GPP's 5G next-gen core architecture. So this draft is related to an existing draft, which is the ICN on LTE and 4G, and which describes how to enable ICN over 4G system. And this current draft describes how to enable ICN over 5G system, but I think what it does, it leverages very similar design principles from the other draft and with some extensions which are very unique to 5G system. So here is a kind of an overview of the updates that are there in this draft compared to the previous version, which was 0.2. So here a new section 5.2.3 has been added, which again borrows the similar design principles from section 4 of the LTE 4G draft 0.3. I think we have a slide which describes some details about this section, and also the section 6, which is new and which replaces the previous section 6 in version 0.2. And some of the sections are left open for future updates. Now, a few slides on the recap. So this is the 5G architecture, and I think the important point here is this draft basically uses some of the 5G design principles listed below, like a service-centric design, distributed LAN support, control and user plane split, decoupling of RAT and core network, and of course this non-IP PTU session support. And also this is the ICN control plane extensions for 5G system that was also described earlier. it is just presented here for a reference. Now, in this new section that is 5.2.3 which is the new section here, which kind of borrows the concept from the LTE draft, which shows a dual stack and where it basically shows how ICN and IP dual stack is deployed over the 5G, and there is a transport convergence layer that has been described. So it can support specifically IP as well as ICN services. Then the new section 6 that is in version 03 describes how ICN can be deployed over a 5G LAN type service. And in that, some of the details that are described there, some of the key features are something which is termed as a path-based forwarding over the NX interface. And to give you a very high-level overview of this method is the path between the source and destination UPFs is encoded in a bit field, and which is provided in the packet header as a path identifier. And each bit position in this bit field represents an unique link in the network through which the information travels. And path identifiers are bidirectional. Then also there is a little bit more details about this path-based forwarding example, where a scenario is described, where sending a packet from one layer to device connected to one UPF to a device connected to another UPF. Then some of the, in section 6, again, some of the keys, IP-based services now that can be enabled over ICN is also described. And some of the key ideas in that are this internet service now as a name service-based transaction, where internet services are now interpreted as the main unit of transfer to be routed over an ICN layer. Then there is also a 4-layer flat protocol stack that is described. And the mapping of the internet services, for example, HTTP to ICN layer is described. So this, it describes how the ICN layer uses an interaction with something called a name resolver to register and discover HTTP-based services. And there is, the last one is the service proxy devices that interfaces to legacy devices and peering networks. So in this section, it also shows and how these IP-based services over ICN is enabled, and it describes the control plane as well as the data plane, and it assumes an end-to-end LAN connectivity to be provided by solutions such as 5G LAN. I think this is the last slide, our conclusions and next steps. Of course, the authors wants to collect feedback from the group, and some of the proposed next steps are we of course address some of the comments that are received in this meeting, and then update section 6 on ICN over 5G LAN architecture. For example, ICN flow management, mobility handling, and ICN over 5G LAN. And we plan to have a demo in the next IETF 105. I think that's it from the presentation. Any comments, questions? I'll be happy to at least try to answer, or if not, I will note it down and pass it on to the authors.
Okay, so if you haven't read the draft, please read the draft and comment. At some point, we need to decide whether to adopt it as an RG draft, so keep that in mind.
Okay,
Thank you.
Bastian?
He's not here. One of us has to give his slides. I'll do it. I'll go do it.
Okay.
It should not take long. So this is a document that has been close to wrapping up for quite a while, and we'd like to wrap it up. Next slide.
Take a clicker.
Oh, right, of course. Great technology. So this started out as work trying to do general ICN terminology, and quickly rat-holed in a major way because we couldn't agree on common terminology for ICN architectures that were significantly different from one another. So we pared it down to NDN and CCN, which also caused a bunch of problems in terms of use of terminology that wasn't identical or even sometimes in conflict between the two. What's happened since is that much of the things that caused NDN to have different terminology from CCN have gone away because NDN's changed their architecture and now is sufficiently similar to CCN that the terms actually mean the same thing. So here's some document history. It's been through a number of drafts. It's actually had fairly wide review. So you can see how it went through here. So there's been sort of like a set of comments from a few people of the last version of the draft. There's now a security consideration section, yay. So the chairs don't believe there are any issues left. And our plan is what we would like to do is to do a IRG review of the draft and send it on toward publication. Unless I will issue a message on the mailing list for basically to see if anybody objects to us doing that. And then we will start the IRSG review if there are no objections over the next few days. Done.
Any comments, questions? And we're getting into a remote presentation.
So we need to.
Yeah.
Oh, let me do a quick introduction. So we have about just under an hour, which is great because to date there's been very little work done to figure out how to do quality of service differentiation for ICN traffic. We've talked about it a bunch. I've given a number of presentations at former interims, and we now have at least 2 drafts proposing solutions to several aspects of this. So the goal for today is first to get a detailed presentation of the new draft that has come in by Anil and Prakash and Milan, and have a discussion of that. We have some input from Cenk and the ICN LOPAN folks about how to, what are the specific considerations for quality of service in low bandwidth and constrained environments. So this I think is our first opportunity with enough time to have a nice high bandwidth discussion to get some advice from working RG participants and stuff as to how important is this? Should we bother? Are we wasting our time? And if not, if we aren't wasting our time, what direction we'd like to take the work in. So think of this as a final kickoff for some real concrete work in quality of service. So I'll turn it over to Anil.
Hey, thank you, dear. My name is Anil Jangam, and I work for Cisco along with Prakash and Milan. So I'll start with thank to the chairs for this opportunity. This is my first presentation in IT. Next slide. So we presented an idea about QoS in last IETF meeting in Bangkok. Prakash did that. And today we have put up to this document or the draft containing this outline here. So roughly the 3 important sections it is like divided in the name-based QoS design and essentially the QoS marker design and how the encoding will happen in the message. The second thing is about the network procedures and how the various ICN network elements like consumer forwarded are going to react to this particular information when it comes into the message. And the third thing is the QoS-aware forwarder design, which is like the main centerpiece of the whole discussion here. And we will talk about certain PIT design enhancements or some of the potential PIT scaling issues that are introduced by this particular mechanism. Next slide, please. So as a motivation for the new QoS design is the need for defining the consumer-driven QoS mechanism. Essentially, when users are requesting for the content, it is the quality of the service which is user is going to demand, depending on the type of service he is actually executing, or the type of the application he is executing, the kind of service plan or the service he has subscribed with the customer, the service provider, and so on. And from that perspective, the second motivation factor is about the design, how the name-based QoS treatment specification is to be done. And after that, we will briefly discuss about the complementary nature between the flow classification, which Dave talked about, and the QoS treatment.
And you are breaking up a little bit. Not sure.
Yes, sorry, I disabled the video. Yeah.
Thank you.
Okay, next slide, please. Okay. So consumer in ICN consumer driven QoS mechanism, essentially it's a pull-based consumer driven mechanism. And is audio also breaking?
It's better now. Continue.
Okay. So it's a consumer-driven mechanism in the ICN, and which directly influences the resource allocation in the network in terms of timing and the rate of interest traffic. Now, the awareness of the QoS context is also with the application, in the sense, as I said earlier, like if application is trying to do a simple video download, or he's trying to participate into a real-time video conference. So depending on the type of service, the quality of service requirement would change, and then that context is only available with the application. And that's the reason the QoS mechanism is basically driven by the consumer. Now, classification aspect is a prerequisite to the QoS treatment. In the sense, identification of flow is certainly is important, but as to once the flow is identified, what kind of treatment is to be assigned to that particular flow is. So from that perspective, the flow classification mechanism that is already available for the review, as well as this QoS treatment mechanism, according to us, it's like a complementary, although they are completely different or independent of each other, but they are important to each other. And once the QoS treatment is identified, how the various network elements will enforce it through their respective QoS over procedures, that we will see in the next section. Can you please go to the next slide? So what we propose from a name-based QoS treatment perspective is that we propose a new type of name segment leveraging the TLV-based design. So essentially, we have the tag length value where the type of TLV, we can leverage the type and then introduce a new metadata field into the name, content name. Now, and then it would allow for then in-place processing of the interest. So what I mean by this in-place processing is that when along with the content name, when we have the metadata associated with it, so the forwarder or the network router is having the whole information within the content name itself. And the other aspect is that the content name is the mandatory field, unlike the optional hop-to-hop headers. That's another possibility where we can put the QoS treatment information or the QoS marker information. But from that sense, from at least our draft perspective, we are proposing to have that in the content name itself. And a very similar mechanism is already widely accepted and used in HTTP-based URLs, where there are certain things like called path parameters or the query parameters. So that mechanism is proven from that perspective. And there are two aspects here. So name base, once we encode the QoS marker into the name, then depending on whether the mutability of the QoS marker is required or not, depending on that, we can either encode it into the content name or encode it into the into the hop header. Next slide, please. So here is the reference model of how the name-based encoding of this QoS marker will be done. So we are breaking up the content name into a routable content name component or the part and a non-routable component name. Now, essentially, the routable is the prefix part, in which we don't really disturb anything as far as the current prefix procedure or processing procedures are there. So only in the end of the whole content name that is that may be provided by the consumer application. Only after that, the metadata encoding will happen. Now, as I said earlier, since we will be defining a specific TLV type or the segment type, the router or the forwarder will be able to detect which name segment contains the QoS marker. Now, as far as the design of the QoS marker itself is concerned, that is still under discussion or under review on our side. That depending on whether it should be a flat naming scheme or a hierarchical naming scheme, in the sense whether we will need one name segment or two name segment, that we are still working on. And the design or the actual encoding of it will also be primarily be influenced by the type of services and then type of the applications that customer is, the consumer application is running. So those aspects are not yet finalized as far as this draft is concerned. So we will see quickly some of the network element procedures here. Next slide, please. So I'll just quickly run through these three things because I want to spend more time on the forwarded design. And then I will request you to look at the draft so that we can have more further discussion on offline. So in the case of consumer procedure, it is aware of users application and its QoS context, as I said in the earlier. So the consumer essentially is going to add the content name depending on what content he is trying to receive, and then it will add the quality marker in the end of the in the content name, and then consumer sends out the interest into the network by performing the QoS marking. Next slide. On the forwarder procedure, and an enhancement to the PIT is suggested here to preserve the where it will preserve the QoS marker into the PIT table. And as I said earlier, since the marker is added into in the end of the QoS, in the content name, it will not affect the LPM process or the least prefix matching process. And the forwarded then forwards the interest based on the result of the LPM. So it is, let's say, assume the LPM process returns like couple of 2 forwarding interfaces or 3 forwarding interfaces. So based on the QoS marker of the individual phases or the the QoS marker that is there in the content, the actual decision will be done based on the QoS marker as to which forwarding interface the interest should be forwarded to. And then essentially the selection of the forwarding interface is nothing but the actual final selection of the queue that the interest the packet will be forwarded or put into for the further processing. And the choice of the forwarding path essentially then becomes the problem of selection of the forwarding queue, as I said. So based on the QoS marking in the interest, so there's a potential case of PIT scaling that we will see in the next slide. Can you please go to the next slide? Yeah, okay. And finally, the producer procedure is like producer will be aware of the disaggregation between the routable name and its QoS marker or that non-routable component, and so that it will look up the content into the cache or its storage only looking at the routable content name, so that disaggregation is kind of identified. And if the content is found in the let's say for example, if the intermediate router finds the content in the content cache, it will also react in the same way. So it will look at the routable content name, and then look up the cache. Next slide. Next slide. So this is again, this is not the final PID design. So essentially, what we are saying here is that in the existing PID design, where we have the interface ID mapping and the content name, we are adding a third column called QoS marker. Now, for the sake of the discussion, we have taken this illustration where we have shown three, or rather two scenarios where the two or more interests are received with the same content name, but with a different QoS marker on two different interfaces. So take a case of interest number 1 and interest number 2. They are received on the two different phases, but the QoS marker is different. And for the sake of discussion here, we are calling it the QoS level 1 and QoS level 2. So essentially, these QoS markers are hierarchical in nature. That's why the order is implied. If we consider them as a flat naming scheme, then it means that QoS marker are kind of independent, having independent values. Now, and in the second case, where there are two different interfaces, interest with 1 and 3 with the same content, with received with a different QoS marker on the same interface. So in this case, phase 1 and interest 1 and 3 are received on the same phase, but they are received with a different QoS marker, which is level 1 and level 3. Now, this is possible in the sense, and this is where the potential PID scaling issue is that when we receive the interest with the QoS lower QoS marker as a first interest, and if we receive another request from a different user but with a higher QoS marker. Now, in this case, since the lower QoS marker would have been forwarded already, and now the second interest comes with a higher QoS marker, now that cannot be aggregated. In the sense, if we have to give the priority treatment to that particular interest request, it has to be forwarded as well. Otherwise, then we are not meeting the QoS requirement. So in that case, the higher level QoS marker interest will also be forwarded, and that's where the little bit of loosening up that PID scaling, or the PID aggregation principle that we have today, that will be loosened a bit, and that's where we are calling it as a PID scaling issue. Go to the next slide, please. Yeah. So essentially, what we are saying is that with multiple interests for the same content with a different QoS marker are received, and since the QoS markers are different, forward both the interest upstream, and then essentially creating two PID entries into the interest level. Now, the net result is that for given content, PID aggregation has to be loosened up, as I said earlier, proportional to the number of unique QoS markers. And how we can address this potential loosening of the scaling issue is by keeping the number of QoS markers limited. Now, again, as I said earlier, the type of QoS markers and and their treatment classification is still not done, but that this is one way of looking at it. In the other assumption is that in real-time cases, we may not hit all this upper bound of the QoS markers all the times. I mean, let's say assume there are 5 levels of QoS marker. Not theoretically it's possible, but maybe practically in real-time case, not all 5 QoS marking level would be received for same given content. So but that's an assumption, and we can by using a hierarchical or partial order of QoS treatment design, we can reduce the scaling requirement. Go to the next slide, please. Yeah, and And this is the way the hierarchical QoS marker or the ordered QoS marker based design will help us to avoid this bit aggregation to an extent. So what the algorithm here is that we will forward the second or the duplicate interest only if it receives with the highest QoS marking. So if any interest that receives with the lowest QoS marking for which an interest is already pending with the highest QoS marker, then we will not forward that in particular interest. And similarly, when we receive the content for that particular interest, in that case, it will satisfy all the interest which are pending below that QoS marker level. Or we can alternatively we can also say that any interest any content that we receive with the QoS marking will satisfy all the interests that are pending. Because ultimately the purpose is to serve the content to the user, but depending on the QoS marking. Next slide, please. The forwarded behavior on the data arrival is the arrival of the data packet to satisfy all the bit entries against the content name in addition to the QoS markers in the data packet. And there are two possibilities depending on the type of QoS marker aggregation that we do in the bit. So as I said earlier, so if the aggregation is done with the highest QoS marker level, then we can satisfy all the pending interests irrespective of the received QoS marker, or we can aggregate the pending interest only with the QoS marker which are less than or equal to the QoS marker in the data packet. So these are the various techniques are to be evaluated, obviously, to understand the performance of it or the impact of each algorithm over the other. And this hierarchical order set aggregation should be more flexible, in our opinion. At least that's what we are thinking, and then it will be performing the data forwarding close to the original QoS marking. But these are yet to be evaluated. So this quick comments on whether the QoS marker design, whether it should be hierarchical or flat, and then I have already covered some of these as points. That the flat naming scheme design of a QoS marker may not help optimize the loss of the interest aggregation at bit, because now from a flat perspective, each QoS marker is independent of each other. So there is no higher or lower as such. So from a aggregation perspective, let's say if we have 5 QoS marker defined, so and if we receive 5 interests with 5 different QoS markers, we will be having 5 interests in the network rather than one which is today without the QoS marker. And from a hierarchical perspective, depending on what kind of hierarchy we come up with, we will have the relatively less number of or impact of on the aggregation. And following factors will govern the selection of the type of QoS markers here. Is the type of service the user is subscribed with the service provider, and then the class of services, or whether the user is doing the video conferencing, audio conferencing, or he's just doing a progressive download and so on. And then RFC 4594, they list down the class service classes that we can leverage or we can refer to. Next slide, please. So these are the advantages that we are seeing here. The flexible scheme by virtue of disaggregation of the routable name component and non-routable name component, and so that both the information is available to the router when it is processing the content name or the name prefix. Both are available at the same time, so that it doesn't have to look up elsewhere, into the optional header or things like that. The QoS marker potentially can be designed to achieve both flow classification or QoS based scheduling in the network, but this is a second level design problem. So far we are saying that both are independent of each other, and we haven't really thought from that perspective whether they can be merged. So we don't have any concrete comment on that, but that is something to be explored. The independence of routable name component from the QoS marker is, we are saying that is not going to impact the fib scaling as such, because there will not be any change into the fib table as we are proposing the change in the fib table. And then there is an opportunity also to implement the QoS over forwarding decisions now, since the content name is going to have the QoS marker inside it. Next slide, please. So this is the last slide. So I'll just cover the future work items here. Is about the evaluate the performance of this name-based QoS marking scheme on the PID scaling or various the scaling issues that we have. We have to study the empirical performance and evaluate the impact of on the PID aggregation and the advantage of the some of the optimizations that we talked about. And design of the naming scheme of the QoS marking itself, markers itself, that is something pending or not yet done. And explore if how QoS marking scheme can also be used for flow classification. Now, this is just an exploration part. We don't have any evidence of it. And explore the use case of in-network mutation in the QoS marker. And depending on whether we need to do the mutation or not, and depending on what kind of values we can get from that particular feature, then the decision or the design of the QoS marker will also be will be derived or will be influenced based on that. So this is it for now in this version of the draft, and we will be working more closely with the community. And then we will already the email has some of the interactions between us and then Dave. He has posted his comment, and there is some feedback that we also added, and we request all the community here to read the draft. It is still work in progress. This is just first version, and we will update it as much as possible based on the feedback that we receive and then some of the ideas that we are having in our mind. Thank you.
Thank you very much, Anil. So this has come quite a long way and has evolved really nicely. So really glad to see that this very comprehensive consideration. Let me just look around the room. Are there any questions, any feedback to Anil? There's one coming up.
So Cenk, Harvey Hamburg. So could we bring up the slide again? Could we bring up the slide again with the PID issue? So where we have this table and the PID table, yeah. So I have a question here. So we are disaggregating the PID entries, and we have a new column, the PID, the QoS marker. Is there actually a table that the forwarders are maintaining with valid QoS markers, or can we just use any QoS marker here?
Sorry. So this table is just a notional here right now. So this is not the real design. And then as far as the QoS level QoS markers are concerned, again, as I said earlier, the design of the QoS marker itself is not yet complete. So the numbers are just numbers here. They don't really mean anything at this point of time.
So what I wanted to get at is, could, for example, a malicious node just use any kind of QoS markers, and then we can disaggregate all PID entries? I mean, is it a problem that we, for example, if we have a malicious node that floods interests with a QoS marker 1, 2, 3, 4, 5, 6 for the same name, and then, yeah, we fill up the PID?
Then it would be the larger thing will be depend on what QoS markers we designed, and then the values will be standardized, right? So any value that is out of the range will be discarded, or that interest will be rejected, will not be accepted. So some kind of validation of that information has to happen.
So let me jump in here. I think I've already communicated this to draft authors. This is a completely unreasonable PID design. But there is a reasonable PID design that doesn't do it this way, that doesn't have scaling problems. And I think I partly explained it in my comments on their draft.
Yes.
Okay, thanks.
Okay. So I think there are no further questions. Thank you very much, Anil.
Thank you.
Looking forward to the next edition of this. Thank you. You can actually stay up. Yep.
So hi, Cenk again, HW Hamburg. These are actually our thoughts on what we want to do with, or our thoughts on the QoS mechanisms. We actually submitted a 0.0 draft yesterday night, maybe. Of course, we probably didn't read it. No. So I want to try to bring it, talk about it now. So what is the picture that we come from? So we have, of course, this constrained IoT constrained network background, and in our use cases, nodes always have limited resources in form of memory, in form of CPU power, and of course, low energy capacities. And our link layers that we use typically have a very low bandwidth and, of course, high delays, latencies, restricted NTUs, and we have a shared wireless media. So we can't use the media all the time we want. We have to share it with other people or with other nodes. So in this environment, we have resources, but these resources are in no relation to the participants, network participants that are actually there. So we have to share the limited resources with other nodes. And our thoughts on this is to first, categorize in the draft, what do we actually have on resources? I mean, what resources are very important for us, and for us, I mean, and also in the IoT environment. And of course, the first thing is we have to think about the link layer resources. I mean, and here I mean like the media access, and this is very low level, but if you go a little bit higher, you have buffer space for forwarding queues, which is independent of the link layer technology itself. And here we can do some optimizations, I presume, later. And we also have PID resources. And PID resources, you can decide, should a PID entry be stored? So the PID placement is important. And of course, the PID replacement, what PID entries can we actually evict to make room for others, other messages or other traffic flows. The first two are actually like short-term decisions for short-term eviction and placement. And the third category is the content store resources. That we have knobs, or we can control about where we want to deploy the content. So we have the first decision, the cache decision, where do we deploy, where do we place the content, and then we have decision which, I mean, in saturated environments, which content do we actually replace. If we zoom in into the link layer resource management first, so it's like I said, we have like resources that we can balance, so we can like configure the number of time slots if we have a Tisch network, the number of channels if we have a BLE network, and stuff like this. We have we can control the latency of packets if we do like a priority-based forwarding using the forwarding queues. And something that we might want to work on later is like a cooperative management, where we can, based on priorities, for example, do some scheduling with participating nodes, with peers, to pre-allocate, for example, resources for returning data packets, because we actually know that we are awaiting something if you send out an interest. If we go to the PID resource, which is more interesting, this is the higher level part, and here we have actually, we can decide on whether the traffic should be like latency, or should have like a low latency, or whether it should have high latency. And of course, the reliability. So we have two dimensions here that we can control with the PID. We can evict the PID entry based on those priorities, or we can, or we can just drop the incoming interest if the priorities are too low for this. And here, of course, we have corporate management's ideas, but this is for future work. This is whether we want to propagate this information on the path or not. Thoughts on the content store itself. And here, I mean, there is already a lot of caching strategies and cache decision strategies out there. But if we have a prioritized traffic, then we can also decide on which dimension we want to optimize for latency, reliability, or both maybe. And this is also, this requires, of course, something. Yeah, I mean, we have to decide on pit placement and pit replacement for this in saturated environments. So there are actually, I mean, if we have a recipe for building like a QoS, then it should probably look like this. We have a traffic flow classification. I mean, this is also a lot of work from Dave in this regard, and we heard a presentation before from Andel. So we do it quite differently. I will show you how in a moment. And of course, we have a priority handling that maps priorities to those traffic flow classes. The classification itself is quite simple, and this is what we want in the IoT. It should be simple, and we don't want to put more information into packets than we need. And here it is, we are actually maintaining a list. This is why I asked the question before. We are maintaining a list of valid classes, and then we have, of course, incoming interest and data packets, so we can obtain a name TLV from those packets, and we can do a longest prefix match on those classes.
Chen, clarification question?
Yes.
Who is we in the sentence?
So we is forwarder.
So the forwarder has provisioned information with
Yes.
this list of prefixes.
Yes.
Okay.
Yes. So we need to provision those nodes and those forwarders with a list of valid traffic classes, and then we do the longest prefix match to find out the class. And here you see some examples where the bold part is actually the class. And this requires no additional information in the packet itself, if you do it this way, and this is what we want. From here, once we have a class, we are defining in the draft that came out yesterday, we are defining these two dimensions that are important, especially in the IoT, which is latency and reliability. And here we have two different priority levels, which is for latency regular and expedited. And for reliability, we have regular and reliable. And those categories or those priorities actually decide on how we evict PID entries, how we evict content store entries. Now, and we come to the Outlook itself. So we submitted this draft, our thoughts on QoS in the IoT, and we want to, of course, bring again results back. And so we want to implement this or parts of that and do some testbed measurements in the large scale. Yeah, are there any questions regarding those thoughts?
I don't have a question. I would like to make a remark because, I mean, submitting the draft so late as yesterday had some reason of lengthy discussions with Schenk and the other authors and the discussions about the subject itself. And what we found is that actually the QoS dimension in the ICN is interesting because you have is more interesting than in the IP world because you have these different mechanisms which you have, and what is even more interesting is that you actually the big effects you can, at least in a constrained environment, produce are from correlating these things. So one example, I mean, one old example, is an issue we already rose in the early days of the ICNRG is the state decorrelation between PIDs. So if you have 3 nodes and each node evicts a PID entry, that actually, and each node takes another one, then you have like decorrelated PIDs that are useless. And the same is also true on the node. If you, I mean, for instance, if you have the cache and the PID, I mean, you have an interplay. So if you, for instance, evict something in the PID, then you should think, what does it mean for your cache and so on. That makes it actually very, very interesting. And I guess it's a richer field than at least the drafts we have written or have read.
Yeah. Good point.
So here's the trade-off, I think, that we need to think about. If you want to be able to infer the traffic classes in the forwarders a priori based on just knowing it, right? You have to configure it, which is what you're proposing.
Yep.
If you're willing to see some interest data exchanges, I would I would point out that the EC3 scheme can actually instantiate that state dynamically at very low cost in overhead on the packets. So if you're willing to not demand that the QoS classification and enforcement happen on the very first packet you see from a consumer, you can look at the data packet coming back, see an EC3 count in there, and then build your table of prefix and class, right? So just something to think about. We may be able to sort of like get the best of both worlds. You might pre-configure some things, but you could also learn at very low cost, as opposed to using ECNT, which is maybe I should have given the classification talk first, but people have heard that before. So maybe something to think about, that we might be able to get the best of both worlds here.
Mm-hmm. Just as a reminder for EC3, this only affects the data traffic, right? You only put this information in the data package. So for the interest, it's already too late.
No, you can put EC3 in the interest.
In the interest.
Oh yeah, sure. If you want. I mean, I don't think it helps. Right? Because the router has to do the flow classification based on the data, based on the name. Right?
Yeah, I mean, we had this. Or what I try to present is here that we also want to do like PID optimizations, and for this you would.
You obviously still need a QoS treatment. This doesn't get rid of the need for the two independent, reliability, latency, QoS dimensions. Let's talk about this and maybe go further on the list. Other comments? Yes, no?
All right.
Thank you.
Thanks.
So, meta question. How many people in the room have heard the description of the flow classification draft and don't need to hear it, don't want to hear it again? Well, the chairs are very interested in not wasting people's time, right? I mean, that's our. How many people would like to hear a recap of the flow classification stuff? All right, put it up.
And there's an exam at the end. So.
If you fail, you have to listen to it once more.
So there's a few changes to this talk based from the last time I gave it, but they're not substantive. And note the bottom of the slide, there's Cisco IPR on this stuff. I no longer work for Cisco, but I think safely claim that because of the way Cisco has donated all the IPR on CCN to be royalty-free, blah, 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 all that based on normal IETF rules. I think it's, now that I'm no longer representing Cisco, I think it's safe for me to tell people that, I don't think this is a problem necessarily, but it has to be disclosed. Okay, so just, setting the stage, we already know there are two aspects to supporting multiple traffic classes in ICN, right? One is, how do you tell the forwarders what the desirable treatment of the traffic is? And the previous talk we heard mostly is basically addressing that problem, although it's not quite clear to me what the boundaries are in that work. The second is, how do you group traffic into equivalence classes so that you can manage the QoS state and tell which packet should get similar treatments, and when you need to do rate shapers, rate limiters, and other forms of ensuring that sources of traffic don't overrun their allocations in the resource manager, how do you decide whose packets are in which equivalence class to do that? So as I mentioned, what the traffic class treatment should be is covered in this draft we just heard about, and this draft I'm talking about here addresses strictly the flow classification problem. So there's some real fundamental deep problems in flow classification. These have been around since the beginning of time, and based on various engineering trade-offs and in some cases the laws of physics, they are probably unlikely to ever change. So if the classifications are too finely granular, either in terms of how many you have at the same time or how quickly they turn over, there's serious scalability problems in the actual resource management algorithms. I mean, this basically has to come down to somebody's writing an input policer / shaper and a scheduler, right, for the resources, right? And we only have certain ways to do that. You can't wave your hands and say, oh, you mean I have to simultaneously track 75 million flows? Gee, that might not work in a core router, right? That sort of thing. If they're too coarse, you can't separate traffic at a fine enough level to have meaningful fairness. So a good example of that in the IP world is, in order to avoid tracking flows, one of the popular algorithms is stochastic fair queuing, where you just hash things into a number of buckets and you ensure that if the hashing works reasonably well, one person can't inject traffic and overload a single bucket. It'll be spread across the buckets and then you'll get some amount of fairness. And that works relatively well if there aren't really sophisticated attackers and you have enough stochastic fair queuing buckets. But SFQ does not actually provide you with good treatment. It just says within a given traffic treatment, if I can't classify the flows granularly enough, I can still do something intermediate between simple class-based queuing and flow clear and pure flow queuing like full WFQ or priority queuing. If it's not securely encoded, what packets belong in which equivalence class, trust across any kind of domain boundary is problematical. And we've seen this with IPDiffServ, right? In the sense that because there isn't a separate way to classify flows, and it can't be managed at boundaries, what do the service providers do when the traffic arrives from somebody else's network? They just stomp on it, right? They just throw it away, right? Because they don't know what to do with it. And they don't want traffic coming in that will take their resources at a higher level of usage than what they locally want to use. On the other hand, if you securely encode this, it makes aggregation somewhere between difficult and impossible. I don't have a proof that it's impossible, but my intuition is that there does not exist a feasible algorithm to take a securely encoded flow classification mechanism and aggregate it reasonably. So differences from IP, we don't have any 5-tuple, and specifically there are no source addresses, right? So we can't use a flow description model like IP does. However, symmetric routing allows the flow state to mirror the fib state, which is very, very nice. You don't need this totally independent data structure that tracks every possible flow that could be entering a router. You only need to track the things that are active at the moment. And the pull-based interaction cleanly separates what the producers desire to be the specifier of traffic equivalence classes from the consumer's desire to control the actual traffic treatment in the network. And there's still, I think, some controversy about how absolute that separation ought to be, and I think we should discuss it further. I'm on record advocating an absolute separation, that only producers are in charge of how flows are classified, and only consumers are in charge of how QoS treatments are specified. So, some constraints here. Equivalence classes have to be bound somehow with the names and the corresponding interest and data packets so that you can maintain stable state across multiple interest data exchanges and be stable across a set of names sharing some common handle. So this argues that it be prefix-based in some way and that the classification be communicated from the producer to the consumer so the consumer knows what the state of affairs is. You can't just use the fib for this. Because it doesn't, the routing, the fib entries are too coarse. Routing prefixes are just too coarse. You would like to have, a routing prefix that looks like CNN or France.gov, right? And you don't want all traffic going to CNN or all traffic going to France in a given part of the namespace. That if that's what your fib has, it's not sufficiently granular to do any useful flow classification. And practical scalable routing needs to do some kind of route aggregation, right? which further blurs the discrimination of these equivalence classes. So you need something that relates to the name structure, provides finer granularity, and hopefully allows you to do some form of aggregation of that. So we'd like a mechanism in the forwarders that is at least as granular as a routable name prefix, and hopefully more granular, without scalability becoming intractable. We want a lightweight encoding and some decent security trade-offs, right? Because there's no scheme that I could come up with Ili or the other people I talked to that both is very, very highly secure and has the other properties we want. So some thoughts on scaling this. What state do you have to keep on a per flow basis when the flow count is very high? We know that you can't build routers that have per flow state when you're running millions of flows through them. For producers and consumers, as opposed to the routers, the state scales naturally with the number of applications and application interactions that are going on simultaneously. So we would argue that you don't really need to worry about how much state needs to be kept around flow classification for consumers and producers. That's not the limiting factor. If an ICN forwarder can't keep all the state, it faces this common problem of which flows to remember and which flows to forget, or how to take a set of flows and without keeping per flow state to be able to do better than just throwing the state away, like doing stochastic fair queuing of some sort. So we don't solve these problems, they're fundamental. But hopefully the mechanisms that have been proposed have some value. So we propose two different mechanisms in the draft, and we do not make any recommendations or statements about which one we should adopt or should we adopt both. One is a name component count in interest in data packets, and the other is an equivalence class name component that binds the equivalence classes directly into the namespace. So let's take a look at the equivalence class component. How am I doing on time? I don't want to take too much more time. I'll go through this pretty quickly. You can read it in the draft. So this is actually very simple. The producer, when it generates a data packet, says the thing has a name, and you count the number of name components starting at the the high end in the name that are considered one equivalence class interest. And this maps reasonably nicely in the sense that people tend to design their namespaces such that as you go down, things are classified into different things. So an example would be if I have a multimedia thing, at the high order part of the name will be like the name of the video, and then then it'll be said, oh, this is the audio and this is the video. And if you count, if you set your count to be as long as the discriminator that discriminates audio and video, you have now separated audio and video into two separate equivalence classes, which means you can give them different treatments. You could put this either inside or outside the security envelope. And this just says, if you put it outside, ICN forwarders can modify it, which is kind of nice because it allows them to manage the flow granularity that they keep. But if the field's outside, there are various attack scenarios that are amplified by this, so that traffic can be split up or grouped in order to attack either the resource managers or the maintenance of the state in the routers, or deny service to people by causing their interests, which packets they want good treatment to get to not be mapped into the right class. Alternatively, we can actually put the equivalence class markers, I don't want to use the word marker, but we can encode the desired equivalence class directly in the name by adding a name component to the names of the content objects. So this has some interesting properties. The first is it's immutable for the lifetime of the associated data, which we could talk about, but seems to be an attractive property for when somebody generates data, they know what equivalence class it ought to be in, and it can stay that way. It's present in the interest packets as well, so that you can use it for both PIT and FIB mapping. And one of the nice examples of this is you can now route differently based on the equivalence class of the interest packet. the other sort of nice property here is that you can actually have hierarchical equivalence classes. It's not that you can only put one in, but you can have a more general classification and a more granular classification both in the name. So for example, if you have layered video, you can say that this is a video stream at a higher order of the name, and then separate, say, layer 0, layer 1, layer 2, which need to be identified in the names of the frames of the video anyway, lower on. And this gives you a form of hierarchical equivalence class or flow aggregation specified by the application as opposed to specified by the forwarders. The other thing is that because this is in the name and controlled by the producer, you may be able to use this for load sharing and QoS-driven demultiplexing of interests of traffic arriving at producers. One other thing I'll mention that is in the draft, is in the slides, is it's nice to be able to use these equivalence classes to control caching algorithms as well and discriminate. So a good example is you could have a cache resource manager that doesn't just evict content randomly based on LFU or LRU or whatever algorithm it's used, but it can say that if I have just evicted a packet in this equivalence class for a user, I might as well evict all of them, or concentrate my eviction for cache space management on an equivalence class basis, right? So I don't spread my cache evictions randomly across all the traffic, all the content that I'm caching, right? And hence have reduced cache behavior across all of the users. So we can use this for cache control as well as for resource control, as well as for link resource control. So consumers can associate arriving data packets with the correct equivalence class and then use that to manage subsequent intrastate exchanges. Now, the subtle consequence of this is if the consumer doesn't know ahead of time what this is, he has to do some intrastate exchange in order to learn the information. The other thing is associated measurements of things coming back, like RTTs and marginal delay. They can help perform flow and congestion management for the equivalence class as a whole in the consumer. So the consumer is not just metering his traffic on a per object, per intrastate basis, but can design his flow control metering across the entire equivalence class. Forwarders, they need flow instance granularity data structure in order to support it. Typically, these are more granular than the prefixes in the fib, but less granular than the names in the PIT, which sort of says, God, my router needs another data structure that doesn't exist today. So you need to actually design this. And as I've said a number of times, there's no magic pixie dust to sprinkle on the flow count scalability problem, right? So what do you do with all this? You can enforce rate control on the equivalence classes as a whole by dropping packets or queuing them in different ways. You can estimate the number of simultaneous flows traversing bottleneck links that can improve performance and congestion. And you can make more intelligent selections of which packets to cache in an ICN forwarder. Prefer cache many packets of the same equivalence class. I already sort of alluded to that. So I'm done. So should we adopt this draft? If we adopt this general approach, should we do both the EC3 and the ECNT schemes? What should we do? So thanks.
I have a general comment on this and also to the other presenters on QS here. To me, it seems that like the reason we're doing this is to better use the resources in the network. And it seems that putting QS markers and things in the name, we're running a risk that people start doing this in a way that we will actually increase the traffic in the network with the factor X something. Even if the answer is that if you do this right, that shouldn't happen, how do we ensure that people don't do it wrong?
So let me ask clarifying question. Is your comment apply both to the definition of equivalence classes and the definition of QoS treatments, or only the definition of QoS treatments?
I'm not sure.
Okay. Because I'm not sure that the equivalence class thing by itself has this property, but certainly introducing QoS markers in the absence of any of some very carefully constructed limitations on how you can use them and what the effect on resource managers is could very easily, have a deleterious effect.
Yeah. So
Just remember, QoS is all about managed unfairness,
yes.
right? It doesn't create new bandwidth. It doesn't make more capacity. All it does is say that I don't care if my traffic makes it through, only that if my traffic doesn't make it through, yours doesn't either.
Yeah, but the thing we really want to avoid is that we start sending the same traffic in a red, green, and blue version, because that I don't think will help. And that I think is an important discussion we should have at some point in time.
Who hasn't signed the blue sheet? More people have come in.
Yep.
Everybody signed?
Hi, Cenk, KW Hamburg. Do we have still time for questions? I mean,
Yeah.
so coming back to the ECNCT, Dave, I think I had a comment on the mailing list before. So basically, what you propose is to have a new name component type.
Correct.
For a name, yeah. So, and in CCNX, for example, you have a plethora of different type name component IDs in the draft. So you can, I don't know, I think it's 2 bytes of unused name component type space. But what if, I mean, if you choose to have the QoS indicator and the name component, then an application won't be able to use any other name component type. I mean, I never used those types actually. I don't know if it is sensible or not to restrict applications from using other types than just generic name component.
Not sure I understand the question.
So, but by putting the QoS marker or indicator in the name component type,
I wasn't proposing that.
the
I was proposing putting the equivalence class, not
Yes.
the QoS
Okay.
treatment.
Sorry, no, I mean the indicator. I mean the indicator of what belongs to the QoS, the traffic classification. Is this restricting the application from doing other component types?
No, of course not.
But a name component can be of type X or it can be of type ECNCT.
Right. So let's say I never know the world before ECNCT. You have a name that would go with regular name component types, CNN, videos.
That's true.
Right. Blah blah blah. All this is saying is you could either, depending on your namespace design, say, oh gee, this name that says video captures what I mean by grouping things together. So I'll use the string video but make the name component type equivalence class. Or if I have an existing namespace and I want to put a cut between the part that should be treated together and the part that should be treated separately, I insert a name component type.
A new one. So it's
in the middle.
In the middle.
Right. So the point is, I think, the trade-off is, in order to do traffic groupings in an architecturally clean way, the producer has to know them, which means that it has to be part of the namespace design. Excuse me, doesn't have to be. I don't know a good alternative other than making it part of the namespace design. And if it's part of the namespace design, it's a mechanical process to either use that name component type in the existing name structure, name syntax, or insert it in the middle.
Okay, thanks. Just one more question, Dave.
It has to be short.
It's too short. So in NDN, you have the possibility to request data by using a prefix. And
Yep.
not, yeah. So do you see implications? I mean,
yeah, I see implications because it's a bad idea to request data by prefix.
Okay. Yeah, thanks.
So but I think you raise a good point, which is that how this explicit ECNT style flow classification interacts with prefix fetch, but in an NDN environment is something I haven't thought about, right? And if we want to support that generally in the architecture, we have to think about it.
Okay, thanks.
If you want to think about it, that'd be great.
All right, I'll try.
So just quickly, so and earlier we discussed this, and I think there was some consensus that this is really great potential, you know, to do QoS differently and you know, potentially much better. Who would have any, you know, issues if we decided to adopt this draft in the future?
Well, we should ask on the mailing list.
We won't decide now. I just wanted to get some feeling from them. Okay, I mean, think more about it. So we want to move forward with this, but if you think it's not the right time or it's completely wrong, please speak up. Okay, thank you. Moving on. Our slide share has disappeared. Yes.
I don't remember how to do it. Sorry.
So, Brooke, you can just edify slides. Sorry for that. Oh dear. Oh man.
The slides are there. We just have to go.
Yeah.
Yes.
I'm like the shortest person in the IETF, right? Always. Okay. Excellent.
Sorry about the delay.
Yeah. Okay. So thanks for all staying around to the end of IETF. This is a call not for work that will be necessarily in this work, in this research group. It's actually a funding call from the European Commission. So it's to call on those that are doing research in this space to reach out to the next generation internet initiative and seek funding. So we all know, hopefully, the internet, but we're proposing to build the next generation of the internet, somehow encompassing European values, as safe for humans, and you know, if it was a washing detergent, even bigger and brighter. So this is there's currently 4 open calls. These are the grant agreement numbers that are running for these projects, and I work for an organisation called Géant. So there was this larger ecosystem of people consulted. Géant is the Association of Research Networks. The RIPE NCC and Centre were also consulted, including Internet Society and even people at the IETF. And this was conducted by NLNet Foundation and Gartner. They did this consultation, whittled down some topics, and this has resulted in a pre-NGI funding call, which will soon turn into a flagship funding call of the European Commission. And so they created this vision document. You can find it if you go to ngi.eu/vision. And this is to try and build the next iteration of the internet, you know, with centered on human values. And so these are the pillars that, that they think that the future internet will be built as part of that. And it starts obviously just with infrastructure, and that's, you know, to be decided. Is this going to be a parallel coexistence on current infrastructure? New layers added in order to use the current internet infrastructure that we all know and love, or sometimes don't love, or will it be entirely new protocols built to support that network? So at the moment, funding calls, there's 4 funding calls in operation. Obviously, this deadline is very, very close. So if you were interested in NGI Zero Discovery or the Privacy Enhancing Technology open call, but don't worry, these open calls cycle very quickly. So they close on April 1st, They also open again on April 1st. And so the project that I'm involved in is NGI Trust. So that may be of some interest to you. You still have time, but these are all part of a pipeline of funding streams from the Commission. So actually there's 4 in operation now. 3 have just closed. They closed this week. So these are for coordinators for this kind of money. And so they'll also be running a series of open calls to encourage people to develop and pilot or commercialize ideas for the next generation of the internet. So specifically, privacy and trust enhancing technologies in the consortia that I'm in, they all have the same sort of money available. So 5.6 million euros to give away. We're only going to be running 3 funding calls in this space, and these are for sort of larger projects. So depending on the maturity of your work and your effort to put time into a proposal, maybe it's not for you, but we do viability projects up to 100,000 euros for pilots, test beds, or validation of your ideas. Execution is a 2/3, 1/3 financing, so you need to find 90,000 euros of your own to be matched with the 180,000 euros that we would offer, and the commercialization is a 50-50 co-share that doesn't take an equity stake in your business if you're going to go to commercialization. Equally, NLNet Foundation coordinate the other project. Very small amounts of money, 5,000 to 50,000 euros, and these projects cycle very, very quickly. So every 2 months, in effect, basically they always have an open call open. You can submit to that. It will close, it will reopen, and they're going to continue until they run out of money. NLNet Foundation also do one on search and discovery under the same conditions, and there's a group called Ledger that are doing one on distributed data and distributed ledger technologies. And they offer up to 200,000 euros also for their project stream. You can find out more on ngi.eu/open calls. If you're in the US, since these are European funded projects, you need to have a focus on Europe and a European partner predominantly, but there's actually an EU-US 2 collaboration projects that are running, Explorers and I think Nexus. So there to work with National Science Foundation partners. So National Science Foundation have a funding stream in the US that's equivalent. And so they're working on bridging the gap between those 2 programs. And this is me, and this is the website. So contact me, and we hope that, a new version of the internet will be built with, based on the research that goes on in this and other groups within the IETF.
Great, thank you very much, Brooke. I hope this community. Okay.
Find a partner in Europe. No, there's nothing specifically done with Canada. So not that we're excluding Canada. In fact, we're excluding large portions of the world. So it's only the EU 28 plus.
And it won't help to rejoin England either.
No,
there's not a.
Anyway, so I hope this community can help Brooke and the EU in general to spend that money wisely. So submit your proposals. Thanks again for.
And actually, it's not spending money wisely, right? Validating that your idea is a bad idea is also worth spending the money on, right? So actually, it's the experimentation, right? It takes that idea off the table if you don't have the opportunity of taking it to a test bed to see if it's good or bad, right?
Yes, right. Thank you. On that happy note, thank you all for coming. We're at the end. We'll do a similar thing in Montreal, so Sunday and during the week. Hope to see you all there. Safe flights home. Thank you. Yeah.
In